Welcome to clickmyproject.com. Let me discuss about the process improved Additive-Wavelet image fusion. Image fusion. The multispectral and the panchromatic images were fused in order to get an enhanced image. So the resulting fused image contains high spatial and spectral resolutions. This has many applications in many remote sensing like that processing. So three types of fusing. First, initially 3 types of nuances were added to the image to both the multispectral and the panchromatic images. So, and they are preprocessed. For preprocessing, we are using median filter. The noise added images are then the median filter removes the noises from the images, and the images were then fused using Additive fusion in order to get a highly enhanced image with a high spatial and spectral resolution. Additive fusion is based on the images transformation coupled with the Fourier divine filtering. This technique is extended to include more than 3 bands by using multiple images transformations until the number of bands is exhausted. A subsequent Fourier transform of the intensity component and the panchromatic image allows an adaptive filter design in the frequency domain. Using the faster Fourier transform techniques, the spatial components to be enhanced or suppressed can be directly accessed. The intensity spectrum is filtered with the low pass filter, whereas the panchromatic spectrum is filtered with the inverse high pass filter. After filtering, the images are transformed back into the spatial domain with an inverse FFT and added together to form fused intensity component with low frequency information from the low resolution multispectral image and the high frequency information from the high resolution image. This new intensity component and the original fused saturation components of the multispectral image forms a new IHS image. As the last step, the inverse IHS transformation produces the fused identity image. Then the performance of the proposed algorithm is measured by calculating some performance measures such as pace and value calculation and MSE value calculation, entropy value calculation like that were done, and the result is displayed here. Thus, we have fused the hyperspectral and multispectral images and have produced the performance software and have proved the performance of our process. Let me discuss about the flow of the process. Improved Additive-Wavelet image fusion. So initially the multispectral images and the panchromatic images were taken and the noises were added to the images. So 3 types of noises such as Gaussian noise, salted pepper noise and speckle noises were added to the image. The addition of noises in the image will create some distortions in the image. These distortions are removed using the pre-processing techniques. So for that we are applying the pre-processing techniques. So here we are using median filter in order to remove the noises from the image. Median filter considers each pixel in image in turn and look at its neighbor pixels to decide whether or not it is representative of the surroundings. Instead of simply replacing the pixel values with the median of the neighboring pixel values, the median is calculated by inserting all the pixel values from the surrounding neighborhood into a numerical order and then replacing the pixels being considered with the middle pixel value. Then the pre-processed multispectral image and the pre-processed panchromatic images were fused using Additive fusion. Additive fusion is based on the IHS transformation coupled with the Fourier domain filtering. This technique is extended to include more than 3 bands by using IHS transformations until the number of bands is exhausted. A subsequent Fourier transform of the intensity component and the panchromatic image allows adaptive filter design in the frequency domain. Each fast Fourier transform techniques, the spatial components to be enhanced or suppressed can be directly accessed. Intensity spectrum is filtered with a low pass filter, whereas the panchromatic spectrum is filtered with an inverse high pass filter. After filtering, the images are transformed back to the spatial domain with an inverse FFT and added together to form a fused intensity multiple spectral image and high frequency information from the high resolution image. The new intensity component under the original hue saturation components of the multispectral images forms a new IHS image. As a last step, an inverse IHS transformation is processed to replace a fused charge in the image. Thus, finally, we are getting a fused multispectral and the panchromatic image. So, and the resulting image is has enhanced spectral and the spatial properties, and the performance of the fusion is also measured by calculating the PSNR value, MSE value, entropy value like that. We are calculating some values and we are proving the performance of our process. Let me discuss the running procedure of the process. Improved Additive-Wavelet image fusion. If you want to run the code, select the file main.m which is included in the source code folder. Select it and right click it, you will get a run file, and when you click it, you will get a window which is required in order to run the code. So first, initially give any multispectral images that is given in the dataset. So here image 1M and image 2M. These are the multispectral images. Give any one of them. So we are giving multispectral images, and then we have to give the corresponding panchromatic images. So here we have to give first image 1, and then we are adding image P. So they were given. So the multispectral images and the panchromatic images were in here. So these has to be fused. Then first we are adding noises to the input images. So first initially we are adding speck Gaussian noise, and then we are adding salt and pepper noise, and finally we are adding speckle noise. So after that we apply pre-processing application. So the images were pre-processed and the result is displayed here. Then this is the fused multispectral and the fused images, fused resulting image. This is the combination of the multispectral and the panchromatic image, and then finally we are measuring the performance of our process. So here this is the multispectral image, this is the panchromatic image, and this is the fused resulting image. So when we click performance measures, the PSNR value, MSI value, spectral angle mapper value, average difference, maximum difference, so these were calculated and the result is displayed here. So this shows that the proposed algorithm has many advantages, and fusing result is very better compared to the other algorithms. So we are fusing the multispectral image which contains several bands, and then panchromatic image is fused and the result is displayed. Thank you.